Hello mate and welcome back to Let's Code Season 6. In this episode we are going to put our player sprite on the screen and put some code in place that will allow us to move it around using the W, A, S and D keys. So this one is another really important one and one where you should finally start seeing things begin to happen. Incidentally, if you are enjoying this content and you want to stay ahead of the game, remember that channel members get early access to all of the Let's Code 6 videos and all of the content on the channel moving forwards. And obviously patrons get the same privileges. So if you are interested in supporting the channel, then by all means hit the join button or visit the Patreon in the description down below. So let's jump right into this then. As you can see, here's a whole bunch of code that we have added to the room class. Yeah, the room class does seem to be inheriting an awful lot of our game code, but that kind of makes sense when you think about it. And what we've got here is 3 class methods for our room class. The first one will allow us to spawn the player in depending on which entrance they've used. The next one will allow us to remove the player, and then the final one will allow us to move the player. So we'll talk through these one at a time. The first method, the spawn player method, requires us to specify the player and also the entrance that they're coming in from. So if this is the very start of the game and we haven't come in through an entrance, then we will obviously have to have a separate string variable for that. As you can see, we've imported the math module so that we can use the ceiling method in order to round up our matrix divisions. And what we've got is if the value of the entrance argument is start, i.e. this is the start of the game and they haven't come in through an entrance, then as you can see we're going to say X is halfway along the X axis of our matrix and Y is going to be halfway along our Y axis of the matrix. In other words, the player is going to spawn in the center of the room. Remember that math.ceil is how we round up. The len is how we get the length of the list in the brackets. And in the brackets, the list that we've chosen for our X coordinate is self.getMatrix0. In other words, the first entry in the first list within our matrix. And then we're going to divide that length by 2 to give us halfway across the screen. And then the same thing in the Y axis. Remember that our matrix is Y dominant. So the first list or the first part of our matrix is actually the Y, hence why we're adding the square brackets into our X and not our Y calculation. So that's what's going to happen if we use start as our entrance variable or our entrance argument. Otherwise, we're going to say if it's north, then we're going to appear halfway across the screen, but at the 0, as in the top of the matrix. If it's south, then it's going to appear in the center again on the right and the x-axis, but the y-axis is going to appear at the bottom of the screen, i.e. length of the matrix -1, remembering that the length of the matrix is how many entries there are, but the actual indices, the index, must be a -1 on that, otherwise we will get a null pointer error. Then we're saying if it's arriving in the east entrance, then we're going to be all the way over to the right hand side of the screen, so the length of the x-axis -1, and halfway down the y coordinates in the screen, halfway down the y-axis. And then if it's coming in the west entrance, then it's obviously going to be 0 on the x-axis and halfway along on the y-axis. And then all we're going to do is we're going to add the player. We're going to say self.getMatrix. Remember that this is the room class, so we're going to say the room's matrix at the x and y coordinates, or yx in this case, is going to equal the player. So we're putting the player in whatever coordinates we've derived from the method. Now remember that this method doesn't have a return type. We're not passing anything back to whatever it was that called it. We're just saying spawn the player, and we're telling it what player and what entrance, so it's doing it. The next thing is just removing the player, and that will become useful in the method afterwards, but all we're saying is remove the player, and we're actually telling it what player to reference just to kind of keep coupling down to a minimum. We could do this without, just by referencing the parent class and things like that, but we're just going to say remove this player from the screen. So all we're doing is we're saying, using our getPlayerPosition method that we wrote a few episodes ago, and we're getting the x and y coordinates of that, and then all we're doing is at the x and y coordinates that the player is at, we're just replacing the player with a 0. That's just effectively removing the player from the matrix. Now the next method is our movePlayer method, and again we're passing in the player, a reference to the player, as an argument, and we're also passing in a vector. A vector is just quite simply a tuple, an X and Y tuple that's telling it how much to move in the X direction and how much to move in the Y direction, for those of you who are unfamiliar with vectors. So again, we are getting the X and Y positions of the player, but this time we're adding vector 0 to the X and vector 1 to the Y. And that's just giving us the new position that we want the player to get to. So we've taken where is the player, add this vector to it. And now we're going to check that our new X and Y coordinates are within the bounds of our matrix. In other words, X must be more than 0, but less than the maximum length of the matrix. And the same for Y, must be greater than or equal to 0 and less than the length of the matrix. If that is true, then we're also going to check that the space we're trying to move to, in other words, get matrix X, Y, or Y, X in this case, is a 0. If it's not, then we don't do anything. We'll just ignore the input from the player. If it is a 0, if there's an empty space in the space we're trying to move, then we're going to call that remove player method. We're going to remove the player from the grid, and then we're going to add it to the new position. So we're going to say self underscore matrix yx equals player. Now I could use the add item method for this, but that does pose a problem, because if you remember, the add item method checks for reserved tiles, which are things, places, spaces on the grid that enemies and items cannot be spawned. However, the player can go on those. So we would need to write an entirely new method which would allow us to put the player in a new position. So it's just easier to just write self.underscore matrix yx equals player in this case, rather than writing a whole new method for it. That may change in the future, but for the time being, that's the most succinct way of doing it. As you can imagine, it's not going to be as simple as just writing those three methods, so there is a little bit of other stuff we need to do. And we're also going to do a tiny weeny little bit of housekeeping just to make sure that everything's where it's best placed. So what I've got here is the game class. What you can see I have done is I've added a new property called current room. It just means that I don't have to keep writing player.getPosition all over the place. I can just say game.currentRoom instead. So all this property does is it gets the X position and Y position of the player, and then it just returns the room at that position within the map. It just makes life a little bit easier for us later on. I've also now added self.setup and brackets into our constructor, which is basically just calling a method. And what I've done within that method in def setup self is I've actually added the self.currentRoom.spawnPlayer command and the start. So when we create this game, the first thing it's going to do is get our player set up and then our game map set up, and then it's going to call its setup method, which is going to spawn the player into the room where it currently is. And then obviously we, for the sake of testing, have created one health potion object and added it to the current room as well. And as you can see, it's a lot more succinct now that I've got that current room method. It means I don't have to keep asking for the player's X and Y coordinates. And I've now added a move player self current room move player vector method also to the game. This just means that when we are adding commands into our screen, rather than having to type game.gamemap.getMatrix to find the player and give it a command, we're just saying to the game class, you move the player and move it by this vector, this XY vector. This method then calls the current room's move player method and passes it the player, or a reference to the player, and gives it the vector property. This just means that the game itself is the thing that's going to receive the command or the input from the player, and then it's going to tell the room instance to run its move player method. It's just a kind of a less confusing way of typing this, basically. You're probably thinking, how is it less confusing if we're telling one method to call another method? But this just makes it a lot more readable. So as you can imagine, now that we've put that code into our game class, we no longer need it in our start label. So back in your script.rpy file where your start label is, this is the content of your start label. Now we're still creating an instance of the game class. We're still reporting input string game created name just to give us a confirmation that that's all working. And then we go straight into our loop. So we're not actually creating any game assets other than the game itself within the start label anymore. We're doing it all Pythonically, so this is a lot more succinct as well. Trigger warning for those of you who get all upset when I talk about how the keyboard mapping for Ren'Py games doesn't have to stay the same for your own game, because that's exactly what we're about to do. In order for us to be able to use W, A, S and D keys in order to move our player around the screen, we have to change some of the key mapping, which means we're going to remove some of the functionality that players might be used to. But this is not a typical Ren'Py game, so it shouldn't matter. And if you get all upset and cry about it, cry more is all I can say about that, to be quite honest. So here we are back in our game object class, where we have our from ABC, import ABC and abstract method statements, if you remember from way back at the start of the series. And what we're going to do is we're going to add these new config.keymap statements to remove the key bindings for these three commands. So config.keymap. Keymap is a dictionary. We're not going to go into dictionaries particularly in this series, but just suffice to say that a dictionary is basically a list, but instead of using indexes 0, 1, 2, 3, 4, 5, it uses keys instead. So the key the accessibility key has a list of keyboard shortcuts in it, and we're removing K_A, which is the A key from accessibility. So pressing the A key will no longer bring up the accessibility menu. We're also changing the director mode. We're removing the key for that, which is no shift key D. In other words, if the player presses the D key, the director will no longer come up, and screenshot will no longer be triggered by the S key. That's what these three statements here do. You need to put them in a Python block, because if you try to put these statements within one of your Ren'Py labels, it's too late. These have already been kind of created and initialized. We need to do it at the very beginning when we're in the init stages of our game. Finally, we need to add our actual keyboard shortcuts. So in our main UI screen, if you remember, we wrote this screen code in the last episode, the last part of the season. We need to now add these commands, key and W, and the action is going to be called to call a function. The function it's going to be calling is game.movePlayer, and the argument that it's going to pass is vector equals 0, -1. S key is going to be 0, 1. A key is going to be -1, 0, and D is going to be 1, 0. And that will allow us to be able to move the player by calling the movePlayer function from our screen code, which means this is literally it. This is how we're going to move the player. And that's all there is to it. It's really, really simple. Using the functionality of Python and the functionality of the Python module within it, we've been able to just move our player with these 4 simple commands, because we've already written the method that will move the player, and all we need to do is pass it the direction that we want it to move in, which is what this is all about. Now, you could have, E and Q and X and Z as your diagonal directions if you wanted to. But we've specifically chosen not to allow diagonal movement within our game, so we haven't got those options there. But it would be a simple case of making sure, using the method that we did in the previous slide, making sure that we haven't got a keyboard shortcut bound to a key that we want to use, and then in our screen, just defining that key to perform one of the functions that we want it to do. So in our game, you can see here I am, and I've got my game loaded. I'm just going to hit the W, A, S, and D keys, and I can move my character around the screen. I can't pass into an object that's already in existence, and if I move to the edge of the screen, I can't push out the edge of the screen either. So that's the character now in the screen and able to be moved around. What I'm probably going to focus on next is how we actually interact with objects within the world. And I think rather than having a specific key in order to pick up an object, we're just going to have, if you're stood next to an object and you try to walk into it, you're going to interact with that object, whatever that interaction may be. We maybe change that further down the line, but for the time being, that's where we're going to stop for today. Thanks very much for watching this, folks. I hope you enjoyed it. Let me know what you think in the comments below, and I will see you in the next one. But until then, you take damn good care of yourselves, all right? Bye-bye.